So with that then, I'm going to invite Rachel Slaybach to come back up, and then one member from each group to come up, and to open up to the audience any questions for any of the presenters so far. We have, I believe there are microphones. Oh, we're going like fancy pants.
Oh.
Okay. Do the thing.
I checked, the last Google Maps said a 40-minute drive.
Tim, where did the judges go?
That is a good question.
Go for it.
You guys are just gonna have to yell. Just gonna go searching. Do we have any questions? Yeah, you know there are questions. Yeah.
Anybody see a microphone?
There you go. Go ahead, John.
I have a question to John, actually.
That's for audience. Oh, and then I'll share one.
Thank you for coming here to talk to us today. The DOE has had some really great initiatives to help promote this kind of innovative thinking in the industry, with GAIN and all sorts of other initiatives in the national labs. Where do you see DOE's role in the future in terms of promoting this kind of thinking in the industry, and what more can DOE do in the future?
Thanks for that. And our role has certainly evolved over the years. I mean, if you want to go back 60 years, right, it was really the government developing the technology, first for the Navy, and then working with companies to commercialize it. I see the government role as sort of a blended role going forward. We've long had a history of government working to innovate in advanced nuclear technology. Certainly, gas reactor technology most recently, but the sodium reactor before that, molten salt reactors, if you go back far enough. And I certainly think some of that will continue, in part because we've got great minds in the national laboratories who I think can contribute to innovation in the nuclear space, in part because I think there are some things that are going to be kind of government priorities, like maybe safeguards by design might be something that's really important to us. Because of our non-proliferation considerations, but may not be something where we're a private company wants to put its first dollar, and so I think there's going to be a role for us. But one of the things that's become apparent to us over the last couple of years, and in events like this, I think folks talked about the innovation workshops we had a year and a half ago or so around the country where we got input from folks. One of the things that became very apparent to us was that there are companies out there that really want to innovate in this space, and they're going to do it. What they need from us is they need help accessing the capabilities and knowledge at our national laboratories, because we've got reactors and hot cells and glove boxes and materials and whatever. The private sector is never going to go replicate on its own. It shouldn't have to. But we've also got people who have done a lot of this work before. We've got data and codes that have been generated. So through GAIN, what we're trying to do is open that door, make it easier for innovators to access that capability and those resources. And then over the longer term, we also want to make test beds available. I worked at the Idaho National Laboratory. That's nearly a 900 square mile piece of real estate in the Idaho desert. There have been 52 reactors built on that site over the years. That's a great place to go demonstrate technology like this. So, and there, DOE has other laboratories too that would make for good sites. So we want to open up that as a possibility as well. We've actually signed a site use permit with NuScale to provide, so they could build on the Idaho National Laboratory site. So that could be an opportunity for innovators going forward as well.
Question for Professor Slaybach. What do you see as the outcome of this? They mentioned some startup costs. Do you really expect this to go to some funding or some follow-up? Or is there a Shark Tank or something? Is someone going to get... I've got some money to invest.
So what do I think is going to be the outcome for the students, for their companies?
For these projects, or the weekend?
Yeah, I have no idea. I mean, really, I think what we were hoping is that these ideas would come, they'd get the experience of what it was like to put one together. And I know some of these groups are really researching how do we incorporate. And I think this is a first sort of vetting of the idea. And I think now they have a lot of enthusiasm and connections to go start really saying, do we want to start a company? Do we want to start a different version of this company? I mean, I think our goal really is to have at least one company come out of this boot camp.
Sir, I don't know if you're an investor, but we would love to have you if you are.
We'll start here, and then we'll go 1, 2.
So I think one of the things that I noticed was that multiple of your companies actually could very easily interact with each other. So nuclear waste company needs regulatory assistance, happens to be a new nuclear regulatory consulting firm who might need, some communications efforts from another. So can you talk a little bit about each of your companies, how you think that they could interact with other companies? Because what has happened in the nuclear industry is we have become us v them sometimes. We don't always deal as an integrated system. So talk about each of your companies. I want an answer from each of you, how you will interact with the other companies up on that part. Thank you.
So that is our whole purpose. That is exactly what ETCH is. It's really bridging the nuclear industry as a whole. And feasibly, we could connect everybody, literally, all of the different startup companies here, to our experts that are already out there and creating some amazing research. So yeah, that's our goal. That's exactly what we seek to do.
Thank you. Absolutely, every single company up here, you're completely correct. ETCH, if we hit regulatory issues and we need answers immediately, we have experts we can communicate with. Hydrogen is just another product that advanced reactors make that makes markets more open, that makes customers more interested, that makes that whole process just much more amenable to us. And it goes down the line. Anything we can do to address regulatory issues from our perspective, and anything we can do to make advanced reactors more likable, more interesting, more valuable to the customer, it's all very, very helpful. So that was an awesome point. Thank you.
I mean, it's kind of the same thing. Right? We could use the communication between our hydrogen facility and the nuclear power plant. Obviously, we're not worried about tracking the personnel so much, but at the same time, if we have a direct communication with the power plant, then we know when we could produce hydrogen, when we couldn't. And then, interconnecting with people all over the world, whether it's individuals who are looking at our technology, or if there's looking for other power plants or other companies who want our product, who need to look at other economical reasons to keep those power plants open. Obviously, currently we don't necessarily need the licensing aspect from the NRC, but at the same time, if they know what we're doing with the power plants and we could get that cooperation between all three, that would make the industry go much better.
Well, that was a great question, but our company is looking more into interacting with other disciplines because we have identified a manufacturer for our beacons, for our Bluetooth beacons, and to create the software and the firmware required to deploy this stuff. Now, this could enable other avenues of communication lines inside power plants. So I'm hoping I get to interact with these guys as well.
Yeah, thanks, Sam. You gave the perfect example. If we're going to be generating electricity from waste, we're going to need some help with some licensing and regulations, and their consulting firm would be perfect. Maybe we could get them to bring the $25 million cost down a bit.
My name is Ron King. I'm with the Electric Power Research Institute right down the road. And first of all, I want to congratulate all you folks because at EPRI, which we call ourselves, we talk about every one of those issues that you guys had. So to get in a room for 2 weeks and be young but come out with actual problems that we actually have that we talk about every day, I think is pretty amazing on your part. Now I want to go to one very specific one because it really affects my life. With the help of the DOE, we just recently finished a project on optimizing the staffing contingent for a small modular reactor. And one of the things that we found there's 6 infrastructure requirements that need to be in place in order to get up the staffing levels where we need to have them. And one of the 6 is personnel location. It's an absolute requirement. But as you noted, that happens in other industries, but it doesn't happen in nuclear. And you mentioned security, but I want to know if you put some thought into the other reasons why it's not happening in nuclear, because I think there are some, and I want to know if you've overcome them.
Very, very good question. Security is a big risk for wireless transmission inside of a nuclear power plant. And the reason we chose to go with the Bluetooth low energy spectrum is that it does not interfere with the current existing equipment even inside the containment. And according to our research and according to the people we've talked to in industry, this is a very doable project. It's just never been done on this scale before. So essentially how the analogy I was trying to make is we are giving people radio towers. Now, if they want to make what kind of radio stations is up to them. And so based on this, you can have dosimeter data that can be transferred back to a main server. Essentially, this is an infrastructure of making the plant smart.
I think we have another question in the middle section.
Hi, my question's for Azul Technologies. What state of readiness is the photovoltaic device, and how long would it take to get to commercial readiness?
So that's a great question. So there's actually 2, they're relatively new technologies, but they're actually already being experimented in the mass manufacturing process. The nanoparticles that make our technology work really well, we actually contacted a supplier, and you can buy hundreds of meters of squared of them. And then the silicon, black silicon photovoltaics are actually being developed in labs for mass manufacturing. So we would probably need about 1 to 2 years worth of experimenting, putting them together, and then we would work with the mass manufacturing plants to figure out a streamlined process to make our specific configuration of them. Does that help?
We have time for a couple more questions.
I also had a question for Azul, so I'll jump on you. It seems like, I know waste is a niche market, but then it seems like La Hague is an even tinier niche. So I'm curious why you went with that very singular site rather than looking at maybe something that's more general like dry casts first. I know you said you might go into dry casts later on, but why not start there? It seems like you'd be more flexible.
So before I hand this off, I apologize because I got to run. Long story, but while I work in DC, I live in Boise, and there aren't a lot of flights from here to Boise. All right, so I'm going to go catch the last one. So thank you all for your time. It's been a real pleasure.
So the reason we were focusing on La Hague and specifically vitrified waste is just the sheer energy density of it. So when we think of the dry storage casks, they have 20 tons worth of spent fuel in that. 96 of that can be used by transatomic. The other couple kilograms is pure cesium, barium, and strontium, that's the waste, the true waste products, and that's what really generates the heat. And so at La Hague, our reprocessing facility, they take all the uranium and the plutonium out and condense it down into these really energy-dense compact canisters. And then for La Hague specifically, we had all their plant data. They put it online. So that was our case study. But yes, you were right. We, towards the end of our project, started looking at what it would take to integrate it into the massive dry storage casks. But we went after the energy-dense stuff first.
Looks like we have one more question.
A question maybe if at least a couple of you could give an insight. This is a 2-week intensive process to get a product put together, which is actually, that's a very real world thing that crops up. Now stepping back, are there any insights about things you would have done differently, knowing what you know now, at the beginning of this, that you could offer so that in the future others can benefit from your experience?
Oh, okay, that's a good.
We're conducting an exit survey.
I think the biggest challenge is getting the groups to work together. Right? I've never met any of the 5 people I've worked with before. Had no idea their backgrounds, and then trying to come together. And I mean, when you put 6 leaders, 6 A personality types trying to argue, even though we had the same concept, the same direction, trying to get us to agree on anything, it basically took a week and a half, and then we had 2 days to do our project. But I think, I mean, just patience and listening to more people and trying to get their aspects and make sure each aspect and each personal opinion is really expressed prior to moving forward. I think that's probably the biggest thing I'm going to take away.
So for our group, I guess one of the things that I learned and that really surprised me the most was that the amount of feedback and the amount of really excited feedback we got. It was amazing to just start talking to a couple people and get just almost pages of response back from them and emails, and then here are 3 more emails you should talk to. These people are the experts in their fields, and it's very much ballooned very, very quickly. And I don't even know if we have a comprehensive list at this point. That was sort of so many people. So the thing that really strikes me now is that we should have started earlier. We should have started asking people, asking experts. One of the hardest questions, I think, is why us? This was tough. We didn't have a lot of experience in this area. I think all of us were technical, so stepping into the policy arena was a challenge and very new for us. So the feedback we got was amazing, and I wish we had just started that process earlier.
So we were very fortunate that we all got along and we all liked each other, and really this was just really fun. It didn't feel like work for us. We, right from the get-go, we established a set of guidelines. We kind of bared it all out. So, a couple weaknesses, a couple strengths, and just really got to know each other at that level. And then we established a decision-making process. So I think keeping ourselves organized and keeping it fun really helped.
Well, I agree with Cindy. We all got along pretty well. But what I loved was how our project evolved over the course of these 2 weeks. We started off thinking, oh, we're going to collect data from reactors and make them operate better. Now, what data? How are we going to collect it? What's our network infrastructure going to be like? And now, from this huge array of cloudy mist, we emerged into this tiny little droplet, which is I don't think the nature of this exercise was to be evolutionary, and I don't think I would do anything different, because even the little bit of hiccups we had were a great learning opportunity.
Yeah, I gotta agree with Stray. When we pitched our ideas in the beginning and just came together as a group of 6 and was just like, all right, let's get electricity from waste, or not even at that point, it was just let's get energy from it. Well, how do we do that? Well, there's like 100 different types of waste, and there's multiple different types being stored in different ways every time. And so it was the whole process of evolution, narrowing it down, what type of technology we wanted to use. But again, I don't know if we could have done anything better. If I knew that, I wish we would have done it. But yeah, it was a great experience overall.
All right, you guys, we're going to close the Q&A with that. Thank you, Ian.